Next problem. Find the finite Fourier sine transform of f of x which is equal to x. X lies between 0 to pi by 2. So pi minus x if x lies between pi by 2 to pi. Given f of x is equal to x. So x between 0 to pi by 2. Pi minus x if x between pi by 2 to pi. That is equation number 1. We know finite Fourier sine transform defined in 0 to pi is given by fs bar of p which is equal to 0 to pi f of x sine px dx. That is equation number 2. So we are going to use 1 in 2. Before that we have to split the integral into 2, right? So two integrals into two integrals. One is limit with 0 to pi by 2 because f of x has two limits, right? One is 0 to pi by 2 and other one is pi by 2 to pi, right? F of x has two values in two different intervals, so that is why we are splitting the integral into 2. So one is 0 to pi by 2 and other integral is pi by 2 to pi. So integral 0 to pi by 2 f of x sine px dx plus integral pi by 2 to pi f of x sine px dx. Substitute the values of f of x corresponding to the intervals. So 0 to pi by 2. So in the first interval x f of x value is right sine px dx. In the second interval it is pi minus x, right? So pi by 2 to pi, integral pi by 2 to pi minus x sine px dx. So that is equal to 0 to pi by 2 x into sine px can be written as derivative of minus cos px by p plus integral pi by 2 to pi minus x. In this case also derivative of minus cos px by p. So using integration by parts, integral u dv which is equal to uv minus integral v du. So find the first integral, integrand x is u and minus cos px by p is v, right? The second integrand u is nothing but pi minus x, v is same, right? Minus cos px by p. So fs bar of p which is equal to the first integrand using uv formula. So u into v, x into minus cos px by p, lower limit 0, upper limit pi by 2 minus integral 0 to pi by 2 v du. So minus cos px by p into dx. This is for the first integral. We are going to second integral. So second integral uv, u is pi minus x into v is minus cos px by p, lower limit pi by 2, upper limit pi, minus integral pi by 2 to pi minus v dx minus cos px by p, derivative of pi minus x, so minus dx, right? So that is equal to minus pi by 2 cos p pi by 2 by p plus second value 0, right? Plus 1 by p integral 0 to pi by 2 cos px dx, right? So second value pi minus pi, then minus cos p pi by p minus pi by 2 minus cos p pi by 2 by p. Pi minus pi 0 in this case, right? The second term, right? Minus integral pi by 2 to pi cos px dx. So that is equal to minus pi cos p pi by 2 by 2p, right? So we are bringing that 2 down, right? Because by in the first term you are having pi by 2, so we are bringing that 2 to the denominator. That is why you are getting 2p, right? So 1 by p, so cos px, integral cos px sin px by p, lower limit 0, upper limit pi by 2. So this is 0, pi minus pi 0. So the second term pi minus pi by 2. So you will get minus pi by 2 minus cos p pi by 2 by p minus 1 by p integral cos px sin px by p, lower limit pi by 2, upper limit pi. So minus pi cos p pi by 2 by 2p plus 1 by p upper limit sin p pi by 2 by p minus sin 0 by p, right? Here plus, so multiplying minus into minus plus pi cos p pi by 2, 2 into p, 2p, right? Minus 1 by p sin p by upper limit by p minus lower limit sin p pi by 2 by p. So 1 by p sin p pi by 2 by p sin 0 0. So here marked in red, so that is minus term, this is plus term, so both will get cancelled, right? So you will get remaining terms. So minus 1 by p sine p pi always 0, so minus sine p pi by 2 by p. So sine p pi by 2 by p into p square plus sine p pi by 2 minus into minus plus p into p square by p square. So 2 times sine p pi by 2 by p square, that is equal to 2 by p square sine p pi by 2.